Humanity has had some wonderfully creative ideas in modern history. However, genius often borders on insanity, and nowhere is this more apparent than the idea of powering a rocket ship with nuclear bombs. People have long dreamed of exploring other planets. I'm sure you're aware of the recent surge in interest in getting humans to Mars. I mean, NASA's just landed a rover there, but I'm sure you're aware that this isn't a new idea. In fact, the Soviet Union had a plan to send people on a flyby of Mars in the 1960s, especially after they lost the race to the moon. However, the rocket they intended to do this with never worked. They also developed plans in the late 1980s to send people to the surface of the planet. However, this didn't happen because, if you know anything about history, to put it mildly, the Soviet Union by this point was, well, flat out broke. However, one idea to send humanity to another planet, including Mars, was Project Orion. Project Orion was a series of theoretical and practical investigations into the possibility of using nuclear bombs to power a spacecraft to get humanity to another planet. The plan was to have a working spaceship capable of taking humanity to Mars and beyond by the end of the 1960s. A vessel would be literally powered by dropping a string of small nuclear payloads directly behind the craft, where they would be detonated. The force of each explosion would propel the craft forwards. If, like me, your first reaction to powered spaceflight using nukes was along the lines of WTF, then the next logical question might be, what prompted such an outlandish proposal? Well, to answer that, we have to travel back in time to the deadliest conflict in human history and its conclusion. World War II saw the first detonation of a nuclear bomb in July 1945. By 1949, Russia had developed and tested its own nuclear bomb. And the Cold War quickly developed into a race to see which major power could deploy the most nuclear bombs in the event of war. And it was out of this desire to put nuclear bombs wherever the US or the USSR wanted that the space race was born. Because if you could put a rocket in space, you could put a nuclear bomb in another country. Then, in 1957, Russia put Sputnik 1 into orbit. Whilst this was just a tiny little thing that went around the world beeping, it was an incredible scientific feat. However, the nuclear ramifications scared many in the United States. So, when scientists said they had the key to interstellar travel, well, somebody was listening. The first person to propose going to space on the back of nuclear detonations was Polish mathematician Stanislaw Ulam in 1946. If you haven't heard of him, he is the person who developed one of the most common methods for solving problems computationally, known as Monte Carlo. Yes, it's named after a casino, and it's still in use today. I've even used it myself to complete some of my physics assignments. And it was Ulam who, along with his fellow scientists at Los Alamos in 1955, wrote a classified report on the idea. Also in 1955, the company General Atomics was founded to investigate the use of nuclear technologies for less destructive purposes. On the back of Ulam's idea, General Atomics created Project Orion in 1958, following the USSR's achievements with Sputnik the previous year. The project soon attracted some of the biggest scientific minds of the age, including Ted Taylor, Edward Teller, who you might remember from Project Excalibur, and Freeman Dyson. If you've heard of a Dyson sphere, then yes, it's that Freeman Dyson. In 1960, NASA rejected Project Orion because they had, well, other slightly more immediate and important projects they were working on. However, General Atomics turned to the Air Force, who actually accepted Project Orion. This was a bit strange as there was no immediate military benefit, and that was normally a requirement that the Air Force had for projects. However, this is where Project Orion would stay the remainder of its days. The basic idea behind Orion's spaceship was surprisingly simple. A number of explosives would be detonated behind the spacecraft to propel it forward. As the atmosphere got thinner, the explosive payloads would get larger. A nuclear bomb would be deployed behind a giant plate called a pusher. As the bomb detonated, the force would be impacted on the pusher, which would propel the spaceship forward. A series of shock absorbers would then work to make the impact of the blast less jarring so that it didn't destroy the ship and its crew. Small-scale tests with plastic explosives showed that this was actually a surprisingly effective method of propulsion. However, unlike spaceship designs of the time, or even now, instead of building small, lightweight craft, the idea was to build big, sturdy ships capable of sustaining the impact of multiple nuclear explosions. General Atomics was a subsidiary of a company called General Dynamics, which at the time designed and built nuclear submarines. So it's not surprising that the design for many of the Orion spacecraft resembled that of submarines. They even had artificial gravity, and the smallest Orion spacecraft was meant to have full living quarters. Bordering on the insane, the largest idea for the Super Orion was meant to be over 400 meters in diameter, as tall as the Empire State Building, and weigh a whopping 8 million tons. That's over 100 times heavier than the largest battleship ever to put to sea, and more than 2,500 times heavier than the largest spaceship ever launched. One method for directing nuclear blasts to propel such a beast was the cassava howitzer, named after a melon because apparently the lab was on a melon kick that year. The cassava howitzer consisted of a nuclear charge in a case. This would help direct the nuclear blast towards a solid propellant. This solid propellant would become vaporized in the intense heat and radiation of the nuclear detonation. The solid propellant would then go shooting out the back in a manner similar to a conventional rocket pushing out burnt fuel, just slightly more radioactive. Unfortunately, not much is known about these devices because they had military applications, so a lot is classified. However, they were proposed as a potential solution to clearing space debris. Quite how setting off nukes in space would help with that, I'm not sure, but nonetheless, it was still an idea people had. It was estimated that it would take 800 nuclear detonations to propel a mid-range craft into space. The idea was to have smaller payload bombs to make the ride gentler on the crew. Each bomb was estimated to weigh about half a ton, with each spacecraft carrying a range of different bombs to suit its acceleration needs. With the exception of our aforementioned big boy that was meant to use hydrogen bombs, each weighing 3,000 tons apiece. General Atomic even approached Coca-Cola at one stage to see if they could collaborate with their engineers, reasoning that if you could move hundreds of bottles around in a factory, you could probably use the same technology to move hundreds of nuclear bombs around in a spacecraft. I would love to have seen the face of the guy at Coke who first had to take that phone call. So, why did the project never literally take off? Well, the main reason, and probably the obvious one, was nuclear bombs. The events of Hiroshima and Nagasaki were still in everyone's minds, and the idea of setting off 1,000 or so nuclear explosions in Earth's atmosphere was not exactly an appealing idea. The scientists working on it even described the eye burn of people watching the launch. And it was conservatively estimated that for every single rocket launch there would be one extra cancer-related death. Quite how they came to this number, I have no idea. Though it was proposed that you might be able to launch one of these things from the Earth's magnetic poles to help stop the radiation being trapped in our atmosphere. But there is a very good reason that we don't launch rockets from Antarctica. These problems were made worse in 1963 with the signing of the Test Ban Treaty. where the major powers of the day agreed to prohibit the detonation of nuclear bombs in the atmosphere, underwater, and most importantly, in outer space.
And with the advice and consent of the Senate, I now sign the instruments of ratification of this treaty.
Even though Project Orion sought an exception to this, none was forthcoming. And in 1965, 2 years later, the project was terminated. Without nuclear tests, there was no way to know if a pusher plate would last the journey into space. And I can't say I'd be too keen on going on a journey with few hundred nuclear bombs only meters away, not knowing if my only shielding was going to last. So, was Project Orion just a crazy idea thought up by mad scientists? Well, probably not. Or at least not entirely. One of the biggest problems with space travel is being able to carry enough fuel without making your spaceship too heavy. And Project Orion pretty much avoided this problem. The project itself was mainly cancelled out of a fear of using nuclear bombs. Whilst this is quite understandable, there were a few potential solutions. One was to use conventional explosives until the spacecraft cleared Earth's atmosphere. Another was just to assemble the spaceship in space, though these may have been ahead of their time. The project also attracted many of America's biggest names in physics, which might suggest that upon further investigation, it wasn't such a harebrained idea after all. Also, there is evidence to suggest that apart from a small resurgence in the 1980s for use in weapons, we haven't seen the last of Project Orion. According to Freeman Dyson's son, George Dyson, NASA purchased more than 1,700 documents concerning Project Orion from him. The idea is that they could make one of these crafts to use to deflect an incoming asteroid towards Earth. The idea is that you could launch a Project Orion spaceship with a week left before Armageddon, and if it all failed, you would still have enough time for a second shot. Project Orion was probably, quite literally, light years ahead of its time, well before the technology to make it work was around. Whilst NASA's current Project Orion makes no mention of nuclear bombs, it's quite possible that one day the legacy of Project Orion will be used to save mankind. Remember, I'm almost a doctor, and until next time, be like a proton. Stay positive. People have long dreamed of exploring other planets. I'm sure you're aware, thought up the